Hi, today we talk about lens. There are two types. One is convex lens, and another is concave lens. For the convex lens, A is also called a convergent lens. It has a shape which is thicker in the middle. Okay, now this is convex lens. Uh, if light pass through the convex lens, it will converge to a point, which is called focus. The second type is concave lens, with another name which is called divergent lens. It has a shape which is thinner in the middle. So, for concave lens, the light ray actually would diverge from a point which is also called focus. Okay? And we need to know how to draw the wave diagram. For the convex lens with a symbol like this. Okay? For concave lens, we have a symbol like this. Imagine that at the center of the lens will be C. If the light ray, if there will be a horizontal line passing through the center of the lens and also perpendicular to the lens, we call this horizontal line is called principal axis. Okay, if light ray passing through the parallel to the principal axis, parallel, you will converge and cut through the principal axis at focus. Okay, we call this focus or principal focus. If uh, now we introduce one more term. The separation between the lens and the focus is focal length. We use f to represent small f. Okay. Similarly, for concave lens, we also have principal axis if it cuts through the center of the lens and also perpendicular to the lens. If the light ray parallel to the principal axis, it will diverge from a point here, which is called focus. And similarly, the distance between focus and lens to be focal length, small f. The symbol is small f. Focal length. Okay, that is the basic for concave lens and convex lens. There are wave diagrams for convex lens. We need to know how to draw wave diagram. Okay, it will be very important in the exam. There will be 3 construction rules to draw the wave diagram. You see, here, if light ray parallel to the principal axis, the light ray would cut through the principal axis again, okay, at the focus point. So this is the rule 1. If the light ray parallel to principal axis the light ray will cut through the principal axis at focus. Okay, and the separation between C and F is the focal length F. Rule 2. If we already cut through the focus, it gives a straight horizontal line. Okay, and this is similar to rule 1. If the light ray travel in opposite direction from right to left, okay, we also give a horizontal light ray out. Okay, now they are similar, right? So please memorize the construction rules. And the last one, the third one, if light ray pointing towards the center of the lens, okay, you will also go straightly. That means low bending is a straight line. Okay, now please remember that. Now we go to the most important point, that is to draw the Venn diagram. For convex lens, there will be 6 cases. Okay, now let's try case 1. U is smaller than F. So convex lens, U is smaller than F. U is the object distance. So we can draw the object like this. Object. Okay, and we know this is object distance, which is smaller than focal length. This is focal length, right? So we have 3 construction rules. Actually, we just need to apply 2. The first one is draw the horizontal line. Okay, and then you pass through the focus. The second one is pass through the center of the lens. The image will be formed at the intersection point between these 2 light rays. So we now need to extend the light ray. Okay, actually the intersection point is in the left hand side of the lens. So we have to draw the dotted line, extend the light ray by a ruler. Okay, so we find 2 extended way. Okay, don't forget it will be a straight line. Okay, and then we find the image is located here. Intersection point located here. This is image. Okay, so we find that the image as long, longer size, larger in size, right? Longer in length. So the image will say this is magnified image. It's bigger than the object. And also it's followed by dotted line, so it's virtual image. That means it cannot project on screen, which is similar to the image followed by pink mirror. And the last one, the image is pointed up, so x the same direction as the object, so it will be erect. Okay, now for the length formula we talk later, but here you see V is greater than U. Image distance greater than U, so it's magnified, right? The second case, U equal to F. So we just simply draw the object at the focus object. And we have to draw the 2 light rays. So the first light ray is horizontal line, which is parallel to the principal axis. Okay, and then the second light ray is passing through the focus. Okay, and then we draw the second light ray, which is point towards the center of the lens. So you will see that there will be no intersection point. What do you think if I draw like this? The light ray actually come from this object. So similar. the property is formed at infinity. Okay, now you need to memorize this. For infinity, we have a symbol. Okay, like this. That is to change the direction of number 8. Okay, 8. Rotate this. Okay, by 90 degrees. So this is, it means infinity. The image is from at infinity, just like if I see the distant object. Okay? We'll talk the lens formula later. And we skip here. Okay? For the third one, object distance is larger than focal length but smaller than 2f. 2f means double the focal length. Okay? Now we have convex lens. So the object is located between f and 2f, just like this. And then we draw the light ray, which is the first way is horizontal line. And then it passes through focus. The second light ray is passing through the center of the lens. Okay, now so we find that the intersection point is here. So that is the location for the image. Okay, so we find a property here. V is greater than 2f. This is V and greater than 2f, right? We talk the lens formula later, and so we skip. And for the property, you see it's pointing down, so it will be inverted. Okay, the object is pointing up, as you see, but the image is pointing down, so it's inverted. And also, light wave form the image, so it will be a real image. If I put a screen at the point of the image, it can project on the screen. Okay, and the last one will be, you see, the size of the image is greater than that of the object. So we say this is magnified. Okay, so we go to the fourth case. U equal to 2f. Okay, can you try this? So U is equal to f, so U here. And then we draw a horizontal line. And then pass through the focus. Okay. This is the first light ray. The second light ray is passing through, is to draw a line passing through the center of the lens. Okay. So you find that the image is located at 2f. I here. So this is a very special case. If U equal to 2f, image distance also equal to 2f. Okay, for the property, can you compare the size of the image and the size of the object? Same, right? So same size. Inverted. and also wheel image. For the fifth way diagram, u greater than 2f. So we draw here object. Okay. So the first lightway is a horizontal line. And then the lightway would pass through the focus. Okay? And then we draw another lightway pass through the center of the lens. So the intersection point is located here. And this is the image. Here we will see V is between f and 2f. If u greater than 2f. Okay, now for the property, you see the size of the image is smaller than the size of the object, so it will be, we will say it will be diminished. That means smaller and smaller, right? Diminish. And also it's pointing down, so it will be inverted. So the image is formed inverted. And the last one will be, is a wheel image. The last one, u is infinity. Okay, now this is not easy. It is a very special one. And firstly, I draw the light ray covering through the focus. Okay, you'll be a straight line, which is horizontal line. And then we draw another way, because we know u is infinity, so it requires the light ray to be parallel to the first light ray. Okay, like this. Okay, now you see parallel. The incident are parallel to each other, right? So because u is infinity, so you can locate the image, which is formed at the focus. So this is image. Okay, image. So V is equal to F. The property, it also diminished. It also will pointing down, right? The arrow is pointing down, so it will be inverted. Okay, that's all for convex lens. You need to know how to draw the 6-way diagrams. You can check this in page 5. Okay, all the 6-way diagrams. Okay, you're able to draw this 6-way diagrams. Now we go to the concave lens. For the concave lens, it also have 3 construction rules. Okay. The first one, the shape of concave lens will be this. So we draw the symbol like this. Okay, equal. So the first rule is, if the light ray parallel to the principal axis, it will diverge from focus. Okay. And the second one, It's the opposite of rule 1. Okay, opposite. So if the light ray pointing towards the focus, you give a horizontal line. And the last one, okay, as you observe, if the light ray entering the center of the lens, you'll be a straight line and no bending. No bending. Just a straight line. Okay? Rule 3. There are two-way diagrams need to draw for concave lens. One is infinity. One is any position except infinity. Okay, now first of all, we draw the concave lens and then any position, so we just draw an arrow somewhere. Okay, the first light ray, you need to know how to draw this. It is a horizontal line. And then it diverges from focus. Okay, and this is the straight solid line in the in the right hand side. And we need to draw another light ray coming from the object here. Okay, it enters the focus. Sorry, enters the center of the lens like this. So intersection point will tell you the location of image. So image is at here. Okay, you'll be dotted line. X is a virtual image. You followed by a dotted line. So we actually it will be smaller than you. We smaller than you. Okay, you give a virtual image. You give a diminished image because we see the image of the size. Because we see the size of the image is smaller than the size of the object. Okay, diminished or one spelling, diminished. Okay, and also it's pointed up, so erect. It's not inverted, it's erect. Okay, the last one, U is infinity. So not easy to draw. And we use rule 2. Point 1, it should be point towards the focus. Point towards the focus. Okay, left hand side is solid line. And then you give a horizontal line. Because U is infinity, so when we draw the second light ray, it should parallel to the first one. Okay, so where is the intersection point? We have to continue. That means we have to extend the light ray for the first reflected ray. Okay, so we will find that the image is formed at the intersection point here. So this is the image I. So we go to F. Okay, and also it will be diminished, virtual, and also erect. It's pointed up, right? Erect. Okay, These are the most important parts for drawing the way diagram in this chapter. You can check these at the page 9. Page 9, yes, okay. Please know how to draw these two-way diagrams. Okay, that's all today. Please have a good practice. Bye bye.